So hi everyone and welcome back to the PT show. In this week's episode, in no particular order, more bicycle safety bulletins, because if I don't do it, no one else does. Exploding tubeless rims and getting gaslighted by the manufacturer. And I hate to say it, but I did call it more wheel failures or effects of wheel failures due to non-captive spokes. We'll look at Jan Willem van Schip's terribly unconventional and ugly to most people's Tubeless, which is modified for road racing. I think is absolutely beautiful. As far as I know, at the moment, legal in terms of its position. There's a grey area whether it's like registered UCI part or not, and we'll come on to that. And then we'll look at some other news and updates from the bike industry and some little updates from me. So let's get started. A little update from me, what I've been testing recently while I've been going through the plethora of gravel tyres, well, mostly mountain bike tyres. I finally ended up ditching the Thunderbirds. I just couldn't get them to work. I recently rode the Gralic, which is quite a rough surface. Not technical, like still dead easy. Anyone can do it. The monkey could do it with your eyes shut. A dead easy gravel ride, but the surface is quite chunky. I ended up with 7 flats on the Thunderbird. I've just given up. Like, if you're stopping that many times to dart a tyre, it's just not fast. So I'm back on the Mezcal XC races. My friend who I was riding with at the time, he's a lot lighter than me. He's only about 70 kilos. He only had like 2 cuts, I think, whereas I got 7. So they're in the bin. I'm still trying to find the holy grail of fast and puncture protected tyres. I mean, they just don't exist, right? It's at two ends of the spectrum. But at the end of the day, if you want a low fast rolling tyre with low hysteresis, it's going to be quite thin. So there's a trade-off there. Anyway, I'm back on the Mezcal XC races. They are absolutely bomb-proof, but they are pretty slow. So let me know down below what I should try next. I don't really want to get into anything below 50 mil. So yeah, there's that. And I've been testing the KOM Silent Drive Hub, which is a silent evolution of the last KOM hub, which had a normal ratchet, albeit the ratchet was on the other side, and it's a tube inside a tube hub, which makes it much stiffer bearing layout than a traditional hub. Now on the Silent Drive one, which features some kind of permutation of a spread clutch, which is working really well. It's dead silent, but it does show up all the knocks and rattles on the rest of the bike. Anyway, that'll be its dedicated review coming soon to the channel. So let's get on to this bicycle safety thing. I mentioned at the beginning we are going to go back to a couple of years ago when I put a video out calling manufacturers, and I've been calling manufacturers for doing this for about 3 years. So since the inception of straight pull carbon spokes on Chinese wheels, and now they're on Western wheels, for manufacturing's sake and ease of machining and low weight of the hub flanges, we saw these side entry spokes. Now, I called it at the time, I don't think they would cause wheel failures, but the effects of a wheel failure could be much worse with this design. And that goes back into kind of like engineering for redundancy, understanding FMEA, which is failure modes and effects analysis. And in this case, it's the effect of the failure, which is quite bad. So I'm not saying, and I never have said, that this design causes failures. It's just when you have a crash or when you have a spoke break or when you have some damage to the rim, what happens then? And it's that knock-on kind of domino effect of detensioning spokes, because it will happen, and whether those spokes can actually stay attached. And we've seen it now. And I hate to be this, but someone sent me a link to the Nero show the other day, and they called me the cycling seer, the guy who sent me the link. I'm not against development of lightweight wheels. I think what we're doing in terms of lightweighting components, it can go further, but you need to be responsible with the design, and you can't reinvent the wheel and take things like captive spokes and J-bend spokes and straight pull spokes and enclosed holes for granted. They're like that for a reason. They have been developed like that for a reason. So yes, when the wheel is under tension, the spokes won't pop out. And if the wheel stays under tension, they'll be absolutely fine. But in the event of a crash, or the rim gets dented, or the spokes break, a wheel is what's called statically indeterminate. So you can't actually easily figure out the other loads and tensions in the other spokes, because you need to know the tensions of the ones around it and the materials of the ones around it. And when one starts to break, or when one here breaks and one here breaks, it's almost like an impossible simulation to compute what happens to the rest of the spokes, because they're statically indeterminate in their structure. So whatever you're going to have some detensioning of other spokes which are still intact. Now, if those spokes detension so much they could just pull out the flange, this is when you get that knock-on effect of just rapid unlacing. And we've seen it so many times now of with these wheels being crashed, not causing the crash, but the effects of the crash are horrific, because basically the rim detaches from the hub, and the hub can stay attached to the fork. And yeah, it's pretty bad. I've seen it The one that the Nero show put out, that was, again, like I said, an effect of the crash that made that worse. And I think Chris Froome had a crash like this, not his most recent crash, I mean, he crashes a lot, but back about a year and a half ago, there's a famous picture of his basically wheel delaced with all the spokes and the nipple head still intact, but basically delaced from the hub. And it's because these things are captive. So what you want to happen is if you have catastrophic detensioning of a wheel and you lose a couple of spokes or you dent the rim, if you've got a straight pull spoke, like an old steel spoke or a J-bend spoke, in an enclosed hole, it won't come out and you'll still be able to come to a stop somewhat sketchily, but you'll probably be able to stop the bike because the brakes will still act on the wheel and the wheel will still be kind of a structure. It'll be loose and wobbly. But if you've ever built a wheel, you can basically hang your weight off that wheel and put it in a frame when there's no tension in the spokes, because as soon as you get a load on that and you put your body weight in it, you tension the spokes and the wheel kind of starts to work. If the spokes aren't there, they can't do that job. So I don't like being proven right. Well, my ego does, but I don't like the fact that this is still happening. And I like I said, I'll continue to call out manufacturers that do this design, and it's just a bit of laziness. It's just a bit of time saving on the CNC machine, machining the pockets from the side and then doing nothing with it. It's really nice to see one of the next generation of wheels have actually listened, and those, even though they're using a similar carbon spoke design, they're now fully captive. It may be a couple more grams on the argument, but honestly, it needs to be done to be safe. And like I said, you can't take all these previous designs for granted and just think you can like ignorantly change it. It is safe when it's in use, and all the spokes of tension is in use. But the mark of a good engineering company or a good designer is that they will see past that and almost have, even though this isn't aerospace, they almost need to have that aerospace like what if. That what if decision making on that what if on the design process, where you think, well, in this level it's fine, but then what if this happens? What will that affect? And then if that fails, what will that affect? And that's what redundancy is, and that's what FMEA is, and it's that kind of thing. And you don't even have to put posh acronyms on it or whatever, but it's just that kind of thinking that needs to be more prevalent in the bike industry, and it isn't. And that leads me on very nicely onto the next subject on carbon wheels. But we keep seeing online through Facebook groups, on Reddit, on Instagram, exploding rims on carbon rims, and it's where like the fairing of the rim meets the sidewall and it's separating. We'll come on to sort of like the gaslighting of the brands who just bury your head in the sand and actually saying it's the customer's fault. So when you see these exploding rims, when the tire's just been on the rim, mounted, it's been sat in a flat, maybe not even being used, sat at someone's house, suddenly it's just gone bang. You start to look at the factors that could be the same in all these fates. So let's go through it. Well, is the air pressure the same? Not always. Is the tire volume the same? Not always, so you can't really link that to it. Is the tire brand the same? No, not always. Some are on Conti, some are on Vittoria. What is the common denominator in most of these, or if not all of these failures? It's that they're being used tubeless. Every single picture of these rims exploding, there's tubeless sealant everywhere. So what's going on here? Well, I've got a theory, and I think this may have happened to Envy last year or a couple of years ago and had a big fix to do. Basically, when you're using your road wheels tubeless, and this never used to happen because you'd never used to use tubeless about 10 years ago, the design really of the rim cavities hadn't changed, is that the cavity under the tyre bed, so under the rim tape, where the spokes attach and the nipples are, that cavity is getting pressurized and essentially exploding because that lower half of the rim, and I'll put the section on the screen in a little CAD that I've mocked up here, this part of the rim is getting pressurized, which never was designed to be a pressure vessel, and is essentially the interlaminar shear between those layers and the sidewall is now exerting a peel on the kind of epoxy in the matrix, and it's just blowing apart. Because that part of the rim was never designed to be a pressure vessel. That part of the rim was only designed really to take radial load from the spokes, so the spokes pulling in. Back when I started road cycling, what was it, 2010 probably, when I really got into road cycling, all the box section rims that I used to ride, aluminium rim brake rims, they always had little pinholes in the fairing. And I'm calling this the fairing. It's not really a fairing, it's just like the lower half of the box section or the extrusion. Those pinholes were basically just for water drainage and ventilation to stop corrosion inside if your wheels got wet. Now, fast forward 15 years or so, we kind of, on a lot of rims, have lost those little pinholes, and it's not so much for drainage, but what has changed between then and now? Well, we never used to run road bikes tubeless. So there was never a risk of getting that pressure down into that cavity. All the pressure that we used to have was contained in an inner tube or a tubular. So that cavity, you didn't have to really have a drain hole. It would never get pressurized. Whereas now, we've gone to tubeless and we haven't actually thought, hang on a minute, what? And this comes back to the whole redundancy thing. And that the kind of foresight in the engineering design, which is lacking in the bike industry, is what happens if this cavity gets pressurized? Can it get pressurized? And the naive argument will say, well, the rim tape was bad. Yeah, that's not good enough because no one checks the QC of rim tape. When the wheels are made in the factory, no one puts the rim tape on and does a leak down test to see if the lower half of the rim is getting pressurized. No one, I guarantee it. And if you are, then kudos to you, but I don't think the big brands are. So the worker puts, or the machine puts the rim tape on, it gets sent out, or the wheel builder puts the rim tape on, it gets sent out, and then anything downstream of that is your problem. And if that rim doesn't have a pinhole or a vent hole, or what we used to call a drain hole in the sidewall, in the fairing, it'll hold pressure if any air gets under the rim tape. Now you think, well, actually no way it could come out by the spoke nipples or it come out by the valve. Well, let's think about all the places, all the leak paths that could easily be sealed up. So if, let's say you've got dodgy rim tape and you pressurize your tire volume and some pressure goes under the rim tape and down into that fairing cavity, what I call the fairing cavity. Now that area of the rim is seriously thin in the layout. And like I said before, that part of the layout is not designed to be a pressure vessel. Currently, due to the spoke loads only, there's nothing pushing that fairing out or those sidewalls out. What that will actually do, if you amplify that effect, is actually try and close those sidewalls. So when you really tension those spokes, if you've got a bulbous U-shaped rim, it'll actually try and close those, and essentially it will superimpose onto the other stresses of the wheel and actually help the glue work to keep those, or help the epoxy within the carbon layers to stay attached. When you look at stress analysis in structures, you can actually get superposition or cancelling out of strains by basically directions of loading. Anyway, that's a topic for another day. But it's not designed to be pressurized. So can the nipples let air out? Not really, because if you look at most nipples that are using carbon rims or aluminium rims, they either have a washer which they seat onto to protect the carbon, or more often not, they're just put straight up against the carbon. Now, the base of a nipple head has basically a spherical, it's like a spherical bearing. It's like a ball and socket. It's spherical and domed. And then because that's essentially relatively hard compared to the soft epoxy of the carbon fiber epoxy matrix, when that gets tensioned by 110, 120 kilos of tension, it makes itself like a little cup, like a ball and socket, and it sticks in there quite hard. And essentially it seals itself very well, especially after it's been turned. It's very well sealed. So you're not going to get much air going out there. So that's a seal. And then if your wheel builder's built it with a bit of Loctite or a bit of spoke prep, that's a quite good seal as well. So you aren't going to get much air leaking out down through the threads. And because the threads are now, when they're under tension, basically the interference fit, you can't get any liquid through there or air through there anyway. And then the only other place to stop the air leaking out is the valve hole. Now, when you clamp your tubeless valve hole with the lock nut from underneath, quite often not, there's a profile O-ring there that, you know, gives the lock nut a nice compression and a nice seal against that spoke hole. So that will probably be a secondary seal as well. So if you do get air in that cavity through bad rim tape, it can't get out, and then the pressure builds, it equalizes with the pressure inside the tire because there's no tube, and then bang, it can let go. And a low pressure will do that to a very thin carbon rim because, like I said, in the layup, those bits maybe not even a millimeter thick. And so if you get that section of the rim and you push it, it's very squishy. If you try and push the sidewall where you need the strength from the hooks pushing out, you can't deform that. It's thick, maybe 1-2 mil thick carbon. This is very mild, and it's not designed to be pressurized. And I think more brands need to take note of that. And I saw a Facebook post recently, which I'll try and find and put in here, where there's a classic example of this. The guy had pressurized his tires up to about 60 psi, left it in the flat, then suddenly it went bang, it was being used tubeless. And the manufacturer said, well, you're using the wrong type of tire, or maybe the temperature went up a little bit. And like, this is not a tire problem. Like 60 psi in a Conti is the same as 60 psi in a Vittoria if it's the same width or whatever. It's like got nothing to do with hookless, nothing to do with tubeless. This is a design error. Like, not putting in a vent hole in the rim. So what I would suggest to you, if you have a rim which you ride tubeless, which I wouldn't recommend riding road tubeless anyway, because it just doesn't really work very well. Like by the time it's actually sealed, you might as well have stopped to put a new tube in and got back to the optimum pressure. But I digress. If you've got a rim without the vent hole and you're running it tubeless and it's got rim tape, I would write to the manufacturer or write to the shop and say, there is a design flaw in these wheels. I believe they are unsafe. At any time, this cavity could be getting pressurized, which is not going to. I'm either going to send it back to you for reworking or replacement, or you're going to let me keep my warranty if I drill a 2mm hole through that fairing and put a vent hole in it. That's what I would suggest. I wouldn't chance it. The only other time where you'd probably be all right is if you get like a fast water rim or something where they do like no spoke holes. You've still got possibility of the air getting down past the valve seat, that conical rubber bit on the tubeless valve, but that's less likely to happen. But do check with the manufacturer if they mind you drilling a vent hole. And if there isn't one, you say, refer them to this video, this timestamp, and say, why the hell not? That was a little bit of safety bulletin, as you all like super excited about that sort of thing. But now we're going to come on to the thumbnail. Probably I'll put this in the thumbnail. And is it an ugly bike? Is it a good looking bike? It's Jan Willem van Schip's Tubeless, which he rides, which he's riding at the moment in the Tour of Holland. Well, he was until yesterday. He got kicked out and disqualified. But before you say this guy's just a chancer, a joke, I think he's actually the Madison or Omnium world champ at the moment. So he's a seriously good track rider. He's been around for a while and copped a lot of hate for this bike. And I just am disgusted by when I read the comments in cycling media about this. No wonder cycling is just seen as an absolute peak of douchebaggery in terms of like the people that follow it, because the Luddite comments that have taken dimly to this bike, yes, it's absolutely mingy, it's ugly, it's got a steeper seat post than Jimmy Savile in a playground, but like it's horrible, but it's function. And here is a guy who's used his brain without top-class power, without top-class CDA, to get to the top level and ride in the Tour of Holland. Yet, just because it doesn't fit with your Instagram flat white aesthetic, you don't like it and you're slating him in the comments saying that he should always be disqualified and not having a chance to race. It's absolutely ridiculous. So, as far as the UCI rulebook goes, this bike is, and has proven to be, completely UCI legal and has the precedent of its being raced in prior races. Now, he's got a bit of a dodgy track record for like headbutting people on the track and being a bit of a dirty rider. But that aside, we're just looking at the engineering, the physics of this bike, because by my point of view, this needs to happen more. A lot of riders in the Pro Tour, they're just given their equipment, they ride it, and that's what they do. They don't really look too far into it. They've got too much other stuff going on with training, nutrition, sleep, breathing carbon monoxide, breathing the exhaust gases off a Vespa, to have a fuck, to give a shit, to do this kind of thing, to use your brain to actually think, how do I go faster? What's the no fastest position on a bike, a TT bike basically? A high stack, a steep seat tube angle, and an open hip, okay? Tall riders, or moderately tall riders, you can't get that on a road bike because the road bike industry is stuck in the UCI rulebook. It's stuck in Instagram, what Instagram says your bike should look like. Jesse and Chris, you're partly to blame. If your bike is slammed and has a massive drop and the seat's like in another county or another time zone, you get likes, right? But that isn't fast for tall people. High stack keeps the hip open. I hate to say it, but flipped up stems for most people in a road TT position are faster if you're moderately tall, over like 185. 6 foot. Bikes don't support it. Any race bike out there, S-Works, Trek, Giant, the stacks are like 50 mil too low. I'm just going to say it. Go and do the aero test on a velodrome. Go and do it with an aero sensor. If you want to go fast in a road TT position, higher stack, if you're tall, is going to be faster. Hip open, steep seat tube angle. Next thing, the steep seat tube on his bike is achieved basically by cutting the existing seat post in half, adding like a mitered cut at an angle, gluing it back on at a different angle, and then wrapping the shit out of it with pre-preg or a wet layup and calling that seat post. So it's still the original seat post. It's just been cut at an angle and bodged back on. Now, it looks odd. But again, I think it's UCI legal because if you look at the UCI stipulation, there is a bit of a grey area here about exemption. They don't specify what exemption is, but on the screen I'll put in the rule book about the setback limitations as of the latest rules. And okay, next year his handlebars will definitely be illegal, but we're just looking at the seat post because apparently that's what he was banned from the Tour of Holland for. It still, I think, satisfies the minimum setback of 50 mil between the tip of the saddle and the bottom bracket center line. A vertical line drawn through the bottom bracket and the saddle. I think there's 50 mil there. So that should qualify. Now, there's some grey area whether the seat post is the registered component in when you get your bike UCI registered. So the frame and the fork. If you look on your frame of the fork, it'll have the little UCI stickers with a little code. Is the seat post part of that frame? If it is, then you're not allowed to do this, and that's that. But interesting to note, actually, the ban came from Switzerland, not from the race at the time. So the commissaires on the ground at the race in the Netherlands, nothing wrong with it, and he's used this setup before and not had a problem with it. It was actually remotely from guys watching in Switzerland said no, ban it. So the Eagle powers that be back in, the nest in Switzerland have got this ban. But I just think it's to be commended. He's not going to have world-class power. He's not got world-class CDA. It's as a tool guy, he's 6'4", I think 194, maybe 6'5". It's hard to be a good cyclist. You don't climb very well because of watts per kilo, and you don't TT very well because of watts per CDA. And you look at climbers, 50 to 60 kilo guys winning the Tour, and the TT specialists, Remco, it's tiny. The big powerhouses, cycling has evolved and the parkour has evolved to not really favour big cyclists anymore. So gone are the days of Indurain, gone are the days of Lance. The big powerful guys can't really cut it anymore. And he's just someone who's used his head to think of how can I go faster. Maybe if you had not made these modifications, maybe you wouldn't even be racing at this level. Maybe you can only get to this. I know for a fact that if I'm on my road TT position, on my road TT bike, I can go 4 or 5 kilometers an hour faster per over an hour than I can on my road bike. But I wouldn't be able to use that in competition. So if you can use that in competition, could I be upper category? Could I be upper level? Could he get to this level where he's racing it? And I think the negative comments surrounding it are just Luddites, and it's pretty tragic. And this is why cycling will always be a kind of cottage industry, because no one wants to use their brain and do something wacky. No one can see the beauty in function, and everyone just goes for form still. And I thought we'd gone past that. And it's obviously there will be guys who think like me, and or Morpheus, Arne is one of them. But for me, I think a good-looking bike is one that's clearly been designed to go fast and optimize the position. And if you're a tool rider and you look at all the lists of bikes that you can get, and these kind of bikes don't support a fast position for tool people, so you have to adapt. Like every bike I get, I have to run maximum spaces. And if you look at my framework bike, this leads me nicely onto the framework bike, which is where I've had free reign over the geometry. The stack on that bike, the head tube looked longer than the Nile, and the seat tube is steeper. That is fully custom geometry, and it's like that. A, because I don't have to run spaces, and it's much stiffer and much more connected feel when you're not hanging off that much skinny ass steerer, which is D-shaped nowadays. Most of them are, so they're not very stiff. And the seat tube angle, I think, is about 75.5. With a straight seat post, that puts my hips really far forward over the bottom bracket. It keeps it very, very open, coupled with a shorter crank, which I think Jan Willen's also using. Climbing, I no longer have to get out of the saddle. Like, I can do the same climb at the same power seated, whereas on my old TCR with the really laid back seat post or something, I'd have to get out of the saddle more to bring my weight forward. Yes, you might think if I put a picture of Instagram, or you might think if I put a picture on Instagram of that bike, down the cafe, it looks odd, doesn't it? It looks like it's got a very long front center, which it does, and a really short back end with a really steep seat tube angle, and a very high stack. But if you take out the skinny tube profiles because they're not aero and stuff, and you actually think, why is it like that? It's the function of that which makes it good looking to me. I think you compare it to like a suit, right? If I went into Marks and Spencer, I'm going to look like a fucking clown if I buy off the peg. I really hope they release the ban on that, because I think it's tragic, and it's just typical UCI. Anyway, a little bit of extra tidbits this week. We've seen Rota, this happened last week actually, we've seen Rota release a brand new group set. Now, Rota was bought by a Chinese company, And you probably already know by now, this is not Rotor as you know them from Madrid. This is basically wheel top EDS. Yes, the group set that I've been riding for about a year now on the Road TT bike. I really hope they've developed that app, because I've been a customer of Rotor for years. Was that Rotor bits on my bike, Rotor cranks. If you go from that level to buying this, you're going to have a big shock. It's not the same company. So you might think, oh, no, the group set's different. But no, this is wheel-top EDS with a skeletonized rear mech. A lot of the parts are still shared. If you look closely, there's a lot of shared parts here. I think the shifters have been reworked a bit. So the ergonomics of the EDS shifters that I've got are made for like 5-year-olds' hands, and very, very small hoods. And I think the Rotor ones are slightly different, but a lot of the hardware and the software will be the same. So if anyone's got that, let me know how you get on with it, if the app is usable, because the wheel-top one certainly wasn't. Anyway, that's been the PT show. I hope you enjoyed that, and I'll see you in the next one.